Hello students, this is Professor Chalai, and in this video we're going to look at pressure volume work. As always, you can follow along with our Chapter 5 workbook. By the end of this video, you should be able to calculate the work done by systems involving pressure and volume changes. Let's get into it. So, for pressure volume work, remember in our previous video we talked about how the change in internal energy will be associated to the heat and the work done by the system. We've spent a lot of this chapter talking about how do we calculate heat changes using specific heat capacity and all of that. In this section, we're just going to talk a little bit about how do we calculate work. And the one type of work that I want us to focus on is what we call pressure volume work, where the work done, so this is the work in units of joules, just like energy, just like heat transfer, is going to be negative the external pressure, just means the pressure of the external pressure of the system. So this is pressure, and usually we're going to measure pressure in atmospheres, right? Because one atmosphere is the pressure of the atmosphere around us at sea level. So it's going to be pressure in atmospheres times the change in volume, right? Delta always means a change, so change in volume. So this kind of work happens when we have some constant pressure, but the volume is changing. And volume is going to usually be measured in liters. Okay, so what that means is that we have joules here, and then we have atmospheres times liters. So we need a way to convert atmospheres times liters, right? Atmospheres and liters to joules whenever we use this sort of equation. And the equality that we're going to use for that is that 1 liters times atmosphere is going to be equal to 101.325 joules. So this is the conversion that we're going to use whenever we need to convert between liters and atmospheres to joules. Those units are the same, and that's how we convert between them. Okay, so let's do some problems where we calculate the work in a couple of systems, number 15 and 16. Here's the equation to calculate the work. Here's the equation to convert the units. I would like to see if you can try this on your own before I even show you how to do them. Try numbers 15 and 16, pause the video, go over them, and then when you're done, unpause, and we'll see if you got the correct answer. Okay, in number 15, we're inflating a balloon and we did pressure volume work on the surroundings. So the balloon did work on the surroundings. You inflate the balloon from a volume of 0.001 liters to 1.85 liters, and the external pressure was 1.00 atmospheres. So let's write those down. Our external pressure was 1.00 atmosphere, which is atmospheric pressure. Our initial volume, so V initial, is going to be 0.100 liters. Our final volume will be 1.85 liters. This just means that our change in volume will be the final volume minus the initial volume. This is usually how we calculate the change in anything. And so that will be 1.85 minus 0.100 liters, or if I did my math wrong, 1.75 liters. That's our change in volume to 2 decimal places. Okay, so then the work done on the surroundings will be negative the external pressure. So the external pressure was minus 1.00 atmospheres times the change in volume, right? 1.75 liters. Let me write that. So work will be negative the external pressure times the change in volume. Okay, so this will give us units of atmospheres times liters, but the question is asking us for the answer in joules, so we'll need to convert that to joules using this relationship right here. And so we'll do that by writing 1 liters times atmospheres is 101.325 joules. So that liters cancel with liters, atmospheres cancels with atmospheres, and our answer is in joules. So our work done, you plug this into a calculator, and you'll get 177 joules, I think, if I plug this in correctly. Negative 1.77. Always remember the negative sign is in front of here. I almost forgot the negative sign there. Okay, so that's how we calculate our work done on the on the environment by this balloon expanding. Okay, let's look at number 16, and if you haven't worked it out yet, pause the video and go over that on your own, and then when you unpause, we'll go over it together. So number 16 says a cylinder with a piston expands against an external pressure of 1.58 atmospheres. So we already know our external pressure is 1.58 atmospheres. The initial volume is 0.485 liters and the final volume is 1.245 liters. So the change in volume is 1.245 liters minus 0.485 liters, which gives us a volume change of 0.700 to 3 decimal place liters. So then our work will be negative our external pressure, so negative 1.58 atmospheres, multiplied by our change in volume, so that will be 0.700 liters. This is in atmospheres times liters, so let's convert that to joules. So 1 liters times atmospheres is 101.325 joules. Liters cancel with liters, atmospheres cancel with atmospheres. And so the work done will be negative 1.58 times 0.700 times 101.325. I get negative 122 joules. Again, the sign is important. Okay. So let me know if you didn't get any of these and where we can go over where you might have went wrong. But in our next video, we're going to talk about enthalpy, which is heat under pressure. I'll see you then. Bye.